Hello, my name is Anna Turshikova. I want to present my survey about target recognition on satellite images. For a long time, people launched a large number of satellites into space. Nowadays, new sensor technologies can provide many multispectrum bounds in spectral and spatial dimensions. Increase the depth of information that can be analyzed by various tasks. One of them is target detection. It is widely used for urban mapping, economic forecasting, forest monitoring, and many other applications. So this task is relevant now, and let's consider state-of-the-art approaches for its solving. First of all, it should be mentioned that there are a lot of challenges with this task. Firstly, there are a large number of different targets, as airplanes, shapes, roads, buildings. Moreover, they have huge interclass and interclass variation. And the second page, you can see different type of airplanes that have different shape, different size, different colors, and different small details, but they all should be ranked to the one class of airplanes. So the usual approaches for object detection are not suitable for solving this task. Also, satellite images are high dimensionality and have a lot of features. So to avoid a small rate between the number of training sets and the number of features, dimensionality reduced techniques or more complex models are required. Moreover, approaches that use spectral features can suffer from similar spectral reflections of different objects or undistinguished properties of targets consisting of similar materials such buildings or roads. Another challenge is dependence on the weather conditions such as clouds or sunlight. One more challenge is that target objects can be have large size, as you can see in the first picture. When object has a large size, you can lose small details, or if a positive it has small size, you can see noise in the picture because of it's constant of different of many um, objects of the same type, or it can be of different types. There's many research just try to deal with this challenge, and let's consider the solutions they provided. The first approach is human-based approaches. After suppose that people when look at the picture, uh, firstly look at the outlining object. So if on a black background there is a red point, attention turns first to it. Thus, authors consider such parameters as intensity and variation. Also, when people see the picture for a couple of seconds, they remember just the general characteristics, where the action occurs, or what are the objects there, many small or some big. Uh, so the authors include both of these uh, features, merge them, and apply a SVM classifier that is widely used in the sphere. Also, they include um, cutting of the big image into small parts, which also widely used for target detection. There are other approach for feature extraction, um, and the next this approach that you can see here avoid cutting for many small images because it's time consumable, and it use edge boxes to uh, find candidate object, after that implement a classifier. There are also many deep approaches, and they show that then deeper is approach, then better performance it has. And it can be as neural networks that have many layers, and it can be just merging of different algorithms as it's provided in the right uh, images for road extraction, and they extract the road characteristic as line shape, the constant widths and parallel boundaries, and each characteristics are extracted by using different algorithms. Also, there are different approaches, deep approaches. One of them are just combining a lot of deep neural networks, as it show in the right images, and some of them I use different neural networks for pre-processing, for example, for prognosing the region of targets. So to conclude, I want to say that there are a lot of approaches, and they vary with features they used, the dimensionality reduction approaches, the classification approaches, and the performance depend on the data they use. Also, the algorithms choosing depends on the goal you have. If you can want good performance, or you can want real-time object detection, or small memory storage. So there is no optimal one approach. And that's all. Thank you for your attention. I'm ready to answer your question. Feel free to contact me by email or phone.